हेलो एवरीबॉडी, कैसे हो सब। अब तो एग्ज़ाम की डेट भी आ गई है तो पढ़ने का मूड हो रहा होगा ना। तो आज हम शुरू करते हैं ग्रेविटेशन। वी विल रिवाइज दिस टॉपिक। यू हैड स्टडीड दिस थिंग इन 11th स्टैंडर्ड, so we will revise all the concept of this gravitation and how to use this concept for solving the question in your JEE and NEET and other entrance exam. Okay, we have to discuss all this thing. So first of all, we will recall which topics we have discussed in this chapter. We had discussed universal law of gravitation. Then we had discussed regarding acceleration due to gravity, small g, how this g varies with height and with depth, that we had discussed. Also we had discussed regarding gravitational potential energy, then intensity of gravitational field, then escape energy, escape speed, and all regarding satellites also. Okay, and we also had discussed Kepler's 3 laws. First law is regarding shape of the orbit, second law is regarding aerial velocity, and third law is regarding time period. Okay, so we will discuss all these things, but within one session we have to complete all these things, so we will go little bit quickly. तो चलिए शुरू करते हैं न्यूटन्स लॉ ऑफ ग्रेविटेशन. दिस इज यूनिवर्सल लॉ, दैट मीन्स इट इज एप्लीकेबल टू ईच एंड एवरी ऑब्जेक्ट ऑफ द यूनिवर्स. You know that every object of the universe attracts all other objects of the universe with a force which is directly proportional to product of the masses of the two bodies, and it is inversely proportional to square of the distance between the two bodies. This force is known as gravitational force. Okay, so if I have two masses, particle 1 has mass m1, particle 2 has mass m2, they are separated by distance r. Then gravitational force acting between these two, magnitude of this force is g m1 m2 upon r square. This g is known as universal constant of gravitation. Why it is known as universal constant? Because its value remains constant throughout the universe. Okay, it doesn't change. That's why it is known as universal. Its constant value is 6.67 into 10 to power minus 11. Unit is Newton meter square per coulomb square. Remember the unit, Newton meter square per coulomb square. Sometimes you have to find the dimensional formula, or you have to use dimensional formula in the entrance exam. So if you know the unit, you can find the dimensional formula. So it is 6.67 into 10 to power minus 11 Newton meter square per kg square. Right? Okay. Now we discuss, ये सब तो आपको मालूम है. अब इसको एग्जाम के लिए किस तरह से याद रखना है और how we can classify it for in different points. Okay, so first thing, this force, gravitational force, is internal force. Internal force means it is acting among the system only, particles of the system. It is not acting from outside. Okay, one more thing, you can say that here force on 1, force on particle 1 by 2 equal to force on 2 by 1. एक्शन रिएक्शन पैर है, जो 1 जितना फोर्स लगाएगा उतना ही फोर्स पार्टिकल 2 will exert on particle 1. So magnitude of both the forces are equal, but remember that the direction is opposite. Why? Because this force is attractive in nature. So particle 1 will attract particle 2. So particle 2 will experience force. Particle 1 is attracting. So it is the direction of force on 2 by 1. In the same way, force on 1. 1 क्या experience करेंगे? 1 will experience force towards 2. 2 उसको attract कर रहा है, तो it will experience force in direction of 2. So this is the direction of F21. You can see both are acting in mutually opposite direction. The magnitudes will be same. As magnitude same and direction opposite, I can say that vector F12 equal to minus vector F21. This shows that equal magnitude, opposite direction. Okay. So if I want to find net force, F net of the system, F net means addition of two forces. Okay, addition of two forces, vector F12 plus vector F21. Okay, both has equal magnitude, opposite direction, hence net will be 0. So here net force is 0, so we can say that it is the internal force. Okay, so as this force is internal, then momentum remains constant. If we assume that no other forces are acting except the gravitational force, then total momentum of the system remains constant. This is law of conservation of momentum, linear momentum. Okay, so here F net is 0. That's why linear momentum of the system remains constant. इतनी बात समझ में आ गई? It is an internal force, and due to that the net force is 0. As net force is 0, total momentum of the system remains constant. Second thing, as net force is 0, center of mass. Okay, can you recall center of mass? You have to, if you are not clear, please go through your textbook and try to recall center of mass. Okay, so we can say that as net force is 0, I can say that F net equal to total mass of the body into A center of mass. Force is equal to mass into acceleration. So this is equal to 0. What does it mean? M, total mass of the system cannot be 0. That's why A center of mass, acceleration of center of mass due to gravitational force is always 0. Remember, acceleration of center of mass due to this gravitational force only is 0. As center of mass acceleration is 0, what does it mean? Velocity of center of mass, acceleration, किसी चीज का acceleration 0 है, what does it mean? Its velocity is constant. So I can also say that velocity of center of mass will be constant. If initially velocity of center of mass was 0, that means initially center of mass was at rest, then after attraction also center of mass will remain at rest. Okay, and if it was moving, it will move with same velocity. So velocity of center of mass will not change due to gravitational force. Remember, velocity of center of mass will not change due to gravitational force. Okay, so this is first point, internal force. Okay, now second point, it is applicable to point masses only. Okay, you have to remember, if it is extended object means it is not a point object but it is a large object. Okay, now then this gravitational force, law of gravitation or this formula is not applicable. Then what is the meaning of point-like object or point masses? See, whenever the two masses are separated by very large distance in comparison to size of the object. So in other words, or in simple words, we can say that if separation between two objects is very large compared to size of the object, in that case the two objects can be considered as point mass even though they are not of point size. And I can consider Earth and Sun. Okay, both are very huge, but even then we can consider Earth and Sun as point mass. है ना मैजिक? क्यों? क्योंकि if we see from very far distance, we can consider Earth and Sun as the distance is very large. The point Earth and Sun can be considered as a point-like particle. Okay, so whenever separation between two objects is very large compared to size of the object, then they can be considered as point masses. And if they are point masses, we can apply this law. So gravitational force acting between Sun and Earth, gravitational force acting between different planets, that can be calculated with help of this law because we can consider them as a point masses. Then it is independent of the medium between the particles. दो masses है, हमने vacuum में रखे हैं, या same at the same separation we are keeping them in water or in some another medium. The gravitational force will not change. Compare it with Coulombian force. Coulombian force में क्या होता है? 12th में पढ़ा है. If medium changes, electrostatic force or Coulombian force changes. Here, medium changes, this will not change because this G is constant, it does not depend on medium. That's why this gravitational force is independent of medium. Okay. Then it is the weakest force. You know that there are four fundamental forces, which are the gravitational force, electrostatic force, strong nuclear force and weak nuclear force. Out of all these four, this gravitational force is the weakest force. Then it is a conservative force. What is the meaning of conservative force? Conservative force is the force in which work done does not depend on path chosen. Suppose I have M1 and here is the gravitational field. In this field, I am moving M1 from point A to point B. Okay, I have to move this mass from point A to point B. Okay, work necessary to move this path is independent of the path. मैं इस path पे जाऊँ या ऐसा करके यहाँ जाऊँ, okay, or I can move on straight line. Okay, whatever path is chosen, path number 2, path number 3, कोई भी path लो, लेकिन work done will remain same. The field in which work done is independent of the path chosen, that field is known as conservative field. So a gravitational field is a conservative field and the gravitational force is the conservative force. आई बात समझ में? Okay. Then next point is it is the central force. What is the meaning of central force? Central force means it is acting along the line joining the two masses. That means देखो हम क्या कर सकते हैं, यहाँ पर एक मास ले लिया M1, यहाँ पर एक मास ले लिया M2. Then this gravitational force always acts along the line joining the center of the two bodies. Okay? Gravitational force always acts along this line. That's why it is known as central force. Remember this thing very clearly in your mind. Gravitational force is the central force, means it acts among the bodies, center of the two bodies. इसके ऊपर हम एक न्यूमेरिकल करते हैं. देखो कैसा क्वेश्चन पूछ सकते हैं एग्जाम. Here I am having question number 1. This is one object with mass m, and here I am having another object with mass 2m. Okay, इसकी हाइट है l, इसकी हाइट भी, इसकी हाइट है 2l. विड्थ दोनों की सेम, हाइट डिफरेंट है. दिस इज l, दिस इज 2l. सो हाइट ऑफ सेकेंड ऑब्जेक्ट इज डबल कंपेयर टू फर्स्ट वन. देन distance between their midpoints is L by 2. Then what is the gravitational force acting between these two? Fg is to be obtained. Okay, now इसके options मैं तुमको देती हूँ. It is 2gm square by L square. Option B, 4gm square by L square. Option C, 8gm square by L square. And option D, 16gm square by L square. Now you just pause the video and try to solve this by your own. Okay? Once you get this, then you can get the solution. I am solving here, but first you have to try by your own. अच्छा, तो अब हम solve करते हैं. See, as I have told you, gravitational force is the central force. That means it acts between center of the two bodies. Here, in your question, it is given that they are point masses. Okay? So मुझको दोनों का center निकालना पड़ेगा. Center of first one is here, and center of second one is here. Okay. Now, what will be the distance between these two centers? I have to find this distance. How can I find? I can use Pythagoras theorem. See, ये पूरा L है, तो सेंटर कितने डिस्टेंस पर होगा? L/2, राइट? ओके, नाउ इसका सेंटर कितना कहाँ पर होगा? This is 2L, so this is at a distance L, so distance between these two, ये हाइट कितनी होगी? L/2. समझ में आ रहा है? पूरा कितना है? ये L है, L का हाफ देखो, ये पूरा L to L. Let me draw the figure once again so you can understand it properly. Here is mass M and its height is L. यहाँ उससे डबल साइज का एक दूसरा ऑब्जेक्ट है, इसकी हाइट है 2L. We want to find gravitational force acting between these two. हम क्या करें? इसका सेंटर और इसका सेंटर होगा यहाँ. I want this distance. So for that I have to use Pythagoras theorem. To use Pythagoras theorem, I must have this distance and this distance. Okay, so this is my, let us say C1, this is C2. In your question, it is given that this is L/2. Okay, now say ये पूरा L है, तो half कितना होगा? L/2. That means this is equal to L/2, right? पूरा उसका half, पूरा L, उसका half L/2. ये L/2 यहाँ से जाता है, तो ये it gives L/2. Okay, because this is L, so this distance is L/2. So using Pythagoras theorem, I can say that, let us say this is P. So C1 C2 equal to under root L/2 square plus L/2 square. That means it is root 2 times L/2. Okay, that is equals to L/root. So C1 C2 is the distance between two centers. Now I have to find this C1 C2 is nothing but our R. So R is equals to L/root 2. What is R? R is distance between two particles, or in this case distance between centers of the two particles, because gravitational force is acting among the centers. So now gravitational force F is equals to G m1 m2 upon r square. So this is G. m1 is m. In your question it is given this is m, this is 2m. So m 2m upon r square will be L square by 2. So this 2 will go over here. So 2 2s are 4. 4g m square upon L square. So this is your correct answer. Okay. So this is the concept. Concept क्या है? Gravitational force is the central force. एक ही बात पर ये पूरा न्यूमेरिकल सॉल्व होता है. Okay. Now let us proceed further. Now let us solve another question. Okay, here it is given that we have two masses, 1 kg and 4 kg. Initially both of them are at rest. Okay, initially both of them are rest. Now, and initially both of them were at infinite acceleration. Now they are allowed to move under the effect of gravity. So gravity की वजह से दोनों अब एक दूसरे की ओर जा रहे हैं सामने. Okay, so at some moment velocity of first v1f, that means final velocity of the first particle is 16 I cap. That means it is towards this side. Okay, it is 16 I cap meter per second. Then what is the final velocity of the second? उस टाइम इसकी वेलोसिटी कितनी होगी दैट वी हैव टू फाइंड। ऑप्शंस आर गिवन हियर, यू कैन पॉज द वीडियो एंड यू कैन सॉल्व इट बाय योर ओन, आफ्टर दैट यू कैन सी हियर। ओके, तो अब मैं सॉल्व करवाती हूँ। देखो यहाँ we have to consider that only gravitational force is acting, okay, no other frictional force or nothing is that we have to assume. It is given in the question that we have to assume. Okay, now here only gravitational force is acting, and we know that gravitational force is the internal force, and as it is the internal force, law of conservation of momentum is applicable. Okay, so according to law of conservation of momentum, total initial momentum of the system is equal to total final momentum of the system. Initially, both of them were at rest. As they were at rest, their initial momentum was 0. Okay, so I can say that here P initial is equal to P final. P initial of first one 0. P initial of the second one is also 0. Okay. Now P final. P final. Okay, so I can say that M1 V1F plus M2 V2F. Okay, as they are at rest, I can say that V1I equal to 0 and V2I is also equal to 0. Okay. So now I can say that M2 V2F is equal to minus M1 V1F. Therefore, V2F is equals to minus M1 by M2 into V1F. That is equals to minus M1. M1 is 1 kg, M2 is 4 kg, and V1F. V1F is 16. So, and 16 I cap. So, it is minus 4 I cap meter per second. So, this is your correct answer. Okay, how many of you are able to solve this? ट्राई करते रहो, कभी ना कभी तो आएगा ही. ओके, सो दिस इज आवर सेकंड क्वेश्चन. नाउ आई वांट टू आस्क यू वन थिंग. सी हियर M1 and here I have another object M2. Only gravitational force is acting on them. Then acceleration of first particle A1 equal to acceleration of the second particle. Is it correct or not? पहले vectorize, okay? And second, magnitude of A1 equal to magnitude of A2. You have to check whether these two are correct or not. A1, vector A1 equal to vector A2, magnitude of A1 equal to magnitude of A2. Yes or no? Yes, then why yes? No, then why no? You have to reply. Okay? All of you have to try for it. You can send your answer either on group or you can give the answer on in the comment box. Okay, अब discuss करते हैं acceleration due to gravity. Acceleration due to gravity means acceleration produced in the body due to gravitational force of any planet is known as acceleration due to gravity. Assume करते हैं अर्थ का खुद का ग्रेविटेशनल फोर्स है. तो सपोज ये बॉडी है, तो इस बॉडी इफ आई ड्रॉप इट, दैट व्हाट विल हैपन? ड्यू टू इफेक्ट ऑफ ग्रेविटी इट विल फॉल टुवर्ड्स द अर्थ एंड इट विल फॉल विथ एक्सेलरेशन. द एक्सेलरेशन प्रोड्यूस्ड इन दिस बॉडी इज नोन एज एक्सेलरेशन ड्यू टू ग्रेविटी. Value of this acceleration due to gravity is different for different planets. So, if we consider any planet, for any planet x, y, z, okay, we are considering one planet. It has mass m planet and radius r planet. On the surface of this planet, an object of mass m is placed. Okay, then gravitational force acting on it, F is equal to, I can say F equal to ma, Newton's second law. Okay, so here A is nothing but g, that is acceleration only. So F is equal to m into g. That means g is equal to F by m. So what is value of F? F is gravitational force, that is g m1 m2 upon r square. m1 means जो force produce करता है, कौन produce करता है? Planet. So mass of planet. m2 जो force experience करता है, and divide by r square. Separation between these two, mass is here. We have to consider the another MP is located at the center. So this distance is RP. So R planet square. This M as it is M kata. So this will be G mass of planet upon radius of planet square. This is general formula for acceleration due to gravity for any planet. Okay, now instead of any planet, if I use Earth, then acceleration due to gravity on Earth will be, here in place of MP, it will be mass of Earth and it will be radius of Earth. So what is the conclusion? This G is inversely proportional to the radius of the planet square. Okay. Now, in this case, we have considered that my mass is on the surface of the planet. If it is not on the surface of planet, but it is at some another height, suppose it is here. Okay, then we have to consider this distance as r. Clear? So actually I can say that G is inversely proportional to square of the distance between the body and the center of the planet. That is G. So G is inversely proportional to, or rather G is proportional to 1 upon r square. Okay. Now let us consider a special case of Earth. We all know that Earth has not uniform radius throughout its surface. On the poles radius is less, on the equator radius is more. It is flattened from the poles, you know these things. Okay. So radius at equator is more, radius at pole is less. So here at equator this r is greater. As r is greater, value of G will be smaller. So I can say that G on equator is lesser than G on pole. Remember this thing. For Earth, gravitation, this G on equator is smaller than G on pole. But see, difference of radius is 21 kilometer. So this variation is also very less, 0.018 meter per second square. That's why for numerical purpose we are considering G as constant, that is 9.8 meter per second square. Okay, so these things you have to keep in mind. Okay, now once again, see, you have discussed or you have understood that G is proportional to 1 upon r square. As r increases, value of G decreases. So Earth की surface से हम जैसे ही ऊपर जाएंगे, value of r will increase and value of G will decrease. So as we move away from surface of Earth, then value of G will gradually decrease. How it changes and how can we calculate value of G at different height? We have one formula here. So variation in G with height. So this formula says that G at height h, okay, G at height h, height means height from surface of Earth, is equals to JE. JE means value of G on surface of Earth upon 1 plus h by re whole square. In 11th standard we have derived this theory. Right now we have to simply accept the formula. Okay. Now if h, that means height from surface of Earth, is very less than re. Generally majority cases में क्या होता है? Suppose यहाँ Earth है. What is the radius of Earth? Radius of Earth is 6400 kilometer. So 6400 into 10 to power 3 meter. And Earth की surface हम ज़्यादा से ज़्यादा कौन सी height लेता है? 10 meter, 100 meter, 1000 meter, like that. Okay, so that value, this h, will be very less compared to 6400 into 10 to power 3 meter. So in majority cases, h is very less than re. So in that case, if h is very less than re, this ratio tends to 0. H by re will be very small. As it is very small, we can neglect it. So it will be and we can use binomial expansion. Can you recall the theory? We had used binomial expansion, and using binomial expansion we had obtained this formula. So G of h is GE into 1 minus 2h upon RE. Okay. Now, so what will happen? Using this formula we can calculate value of G at different height. Now, how this is useful? In your exam they can ask you value of G on surface of Earth is this much, then what is the value of G at this much distance? Okay, or what is the change in value of g. Either they can ask you absolute change, they can ask you fractional change, or they can ask you percentage change. So absolute change means value of g on surface of earth minus value of g at given height. That is the absolute change. By putting the formula, you can get this one. So g is equals to GE, rather you can say this is GE into 2h upon RE. Simply they have given you distance. Then at the height of 50 meter, what is the decrease in value of g? So simply by putting the value, what is h? H is given as 50 meter. Radius of earth 6400 into 10 raised to 3 meter. Value of g 9.8. You can calculate the change. So this is absolute change. They can ask you what is the fractional change in value of g. Fractional change means delta g by g. Okay. So delta g by ge. So this g will come over side. It will be 2h upon re. And if they ask you percentage change, then delta g by g multiplied by 100. तो अब देखते हैं वेरिएशन इन जी विथ डेप्थ. अर्थ की सरफेस से जैसे जैसे अंदर जा रहे हैं कैसे जी की वैल्यू चेंज होती है. ओके, सो द फॉर्मूला दैट वी हैड डिराइव्ड इन आवर थियरी सेशंस इज जी ऑफ डी इज इक्वल टू जी ई इनटू 1 माइनस डी बाय आर. व्हाट इज डी? डी इज डेप्थ. हमारा बॉडी यहाँ है जो अर्थ की सरफेस से डी डेप्थ पर है. सो डी रिप्रेजेंट डेप्थ of the body from surface of earth. So GE into 1 minus d by RE. Once again RE is radius of earth and GE is value of g on surface of earth. Okay, so we can say that this is RE minus d upon RE. LCM or कुछ. So see here RE is constant, GE is constant. So I can say that value of g at any depth is proportional to RE minus d. So जैसे जैसे ये depth बढ़ेगी वैल्यू ऑफ जी डिक्रीज होगी. एज डी इंक्रीजेस वैल्यू ऑफ जी डिक्रीजेस. सो एब्सोल्यूट डिक्रीज कैसे फाइंड करते हैं? ऑन डिफरेंस सरफेस ऑफ अर्थ वहाँ पर मैक्सिमम होगी, ये उसका जो डिक्रीज हो रहा है. ओके, इतनी दिस इज द वैल्यू एट डेप्थ डी एंड दिस इज द वैल्यू ऑन सरफेस. दोनों पर डिफरेंस लेंगे हम वी विल गेट एब्सोल्यूट डिक्रीज. Fractional decrease लेना है, then delta g by ge that will give me d upon re, and whenever we get percentage delta g by ge multiplied by 100. Okay, so what we can say okay, from one more thing, what will be value of g at the center of earth? Center लेते हैं तो डेप्थ कितनी हो गई? अर्थ की सरफेस से कितना डिस्टेंस हो गया? This is equal to re. In that case, d will be re. If d is equals to re, what will be g of d? G of d will be 0. So, what we can say, at the center of earth, acceleration due to gravity is 0. Then, from center, here it is 0. Okay? As you move towards the surface, g increases, increases, increases. At the surface, it is maximum. As you move away from the surface, again value of g decreases. So at the center, once again try to recall, at the center value of g is 0. From center as you move towards the surface, अभी हो कहाँ पर? अर्थ के अंदर ही. So value of g increases, 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 increases. At the surface it becomes maximum, and as you move beyond the surface, once again value of g decreases. 0 increases, 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 becomes maximum. So value of g is maximum on surface. And as you move away from the surface, once again value of g decreases. Got it? Okay. Now, ये तो हमने टेक्स्ट बुक में भी देखा था. Now there is one more cause for variation. Earth rotate हो रही है. You know, Earth is rotating, and due to this rotation, value of g also changes. So this is the new point, this is the additional point for you. Variation in g with latitude due to rotation of earth. Okay, what is the meaning of latitude? First of all, suppose इस place P का latitude find करना है, then latitude lambda is the angle between the line joining the place with the center. यहाँ से जो place है वहाँ से center को join करो, एक line मिल गई, उस line का equatorial line. This is my equatorial line. Equator होगा यहाँ पर अर्थ का. Okay, so angle between this equatorial line and the line joining the place with the center of Earth, that is known as latitude. Okay, now at different points latitude will be different. Okay, at इक्वेटर पर ले लो, सो इक्वेटर पर लैटिट्यूड 0 होगा. पोल्स पर जाओ, यहाँ लाइन यहाँ से यहाँ आ जाएगी, सो पोल्स पर लैटिट्यूड मैक्सिमम दैट इज 90 डिग्री. ओके, so as latitude changes, value of G will also change due to rotation of Earth. We are considering that our Earth is rotating with angular speed omega. Then what is the value of G? Here is the formula. You have to remember this formula. So G dash is equal to G into 1 minus RE omega square, omega angular speed, cos square lambda upon G. You have to note it down. Okay. Now, how the value changes? At equator, as I have told you, at equator lambda equal to 0. If lambda 0, cos 0, 1, so it will be G into 1 minus RE omega square upon G. If you simplify, you will get G minus RE omega square. जो पोर्शन हम सब्ट्रैक्ट कर रहे हैं वो पोर्शन मैक्सिमम होगा, बिकॉज कॉस की मैक्सिमम पॉसिबल वैल्यू 1 कॉस स्क्वायर की, सो हम 1 ले लेते हैं. So this is minimum possible value. So due to rotation, कहाँ पर minimum है? Equator. In the same way, if we consider poles, at poles lambda equal to 90, cos 90 0, so it will be G dash equal to G 9.8 fixed होगा. Okay, which is the maximum possible value. So all this is regarding variation of G. तीन चीज़ों से variation होता है. Due to height, variation with height, variation with depth, and variation due to rotation of Earth. Okay. इतना डिस्कस करने के बाद, now we have to discuss about intensity, gravitational intensity. We can compare this topic with our electric field. Gravitational field, electric field, काफी similarity. Okay, let us discuss it. Now let us discuss intensity of gravitational field. Okay, ये 12th में जो पढ़ा है उसके साथ कंपेयर करते थे. 12th में हमने पढ़ा इलेक्ट्रिक फोर्स F is equals to QE. So you can compare it now. Gravitational force, इलेक्ट्रिक फोर्स किसकी वजह से है? चार्ज की वजह से. ग्रेविटेशनल फोर्स किसकी वजह से है? मास की वजह से. So gravitational force is equal to mass multiplied by, this is intensity of electric field. Here I have to write intensity of gravitational field. So F of Fg is equal to m into I. Now, one more thing. Suppose we have two masses, m1 and m2. They are separated by distance r. Then, ये दोनों masses, they are producing gravitational force. So, suppose we are considering one point here. One mass is kept here. Then ये m1 इसको इस तरफ खींचेगा, m2 इसको इस तरफ खींचेगा. So, this body will experience two forces in mutually opposite direction. If magnitude of both the forces will be 0, then what will happen? ये इस पार्टिकल के ऊपर 0 फोर्स लगेगा. So the location at which 0 कहाँ पर लगेगा? इन दोनों के बीच में कहीं पर भी 0 हो सकता है. तो जहाँ पर भी 0 फोर्स मिलता है उस पॉइंट को हम नल पॉइंट बोलेंगे. Okay, so this n represent null point. So what is the null point? Null point is the point at which if any mass is kept, it will experience 0 gravitational force due to these two masses. Okay, so in exam you are required to find the location of this null point. Okay, you can solve it with help of our conventional method, that is force due to this one is equal to force due to this one. Then simplification करके तुम लोग कैलकुलेट कर सकते हो. But there is one shortcut. जैसे मैंने इलेक्ट्रिक फील्ड में भी इस तरह की शॉर्टकट दी थी, लोकेशन फॉर नल पॉइंट फाइंड करेंगे. सिमिलरली हियर आल्सो वी कैन फाइंड द लोकेशन ऑफ द नल पॉइंट. सो डिस्टेंस ऑफ नल पॉइंट, हियर आई हैव कंसीडर्ड दिस इज माय नल पॉइंट. इट इज एट द डिस्टेंस x फ्रॉम मास m1. टोटल डिस्टेंस इज r. सो डिस्टेंस ऑफ नल पॉइंट फ्रॉम m2 इज r minus x. So distance of null point from mass m1 can be obtained by separation between distance two masses, that means r, divided by under root m2 by m1. See, keep in mind you are finding distance from m1. m1 से distance ले रहे हैं तो m2 by m1 आएगा, अंडर रूट m2 by m1 plus 1. And suppose I want to find distance from m2, then only change will be there. यहाँ m2 से distance ले रहे हैं तो यहाँ m1 by m2 मिलेगा. Okay. So using this formula, quickly you can find the location of null point. Let us consider an example. Suppose m1 is 1 kg, m2 is 16 kg. Let us consider, or let us say 9 kg. And R ले लेते हैं 16 meter. Then my distance from, or I can say x equal to, separation कितना है 16 divided by under root x is distance from m1. So m2 by m2 is 9 by m1 is 1 plus 1. 9 by 1, that is 9. Square root of 9 is 3. 3 plus 1 4. 16 by 4, that is 4 meter. So location of the null point is 4 meter from mass m1. As it is 4 meter from mass m1, from m2 it will be 12 meter. Okay, you can calculate here. So from this you must be able to understand that m1 was smaller. So keep in mind that null point is always nearer to smaller mass. Note it down. Null point is always nearer to the smaller mass. Okay, ये पॉइंट दिमाग में रखना है. और हाउ कैन नियरर टू द स्मॉलर मास, एंड डिस्टेंस का कैसे मिलेगा? सेपरेशन डिवाइड बाय m2 by m1 plus 1, root m2 by m1 plus 1. Now one more point, this I, intensity. What is the relation between intensity and potential? Potential is here we have to consider gravitational potential. In 12 we have obtained E is equal to minus dV by dr. इलेक्ट्रिक पोटेंशियल का डेरिवेशन करोगे, इलेक्ट्रिक फील्ड मिलता है. सिमिलरली हियर ग्रेविटेशनल पोटेंशियल का पोजीशन के रिस्पेक्ट में डेरिवेशन लेते हैं, वी कैन गेट इंटेंसिटी ऑफ ग्रेविटेशनल फील्ड. बट आफ्टर डिस्कसिंग पोटेंशियल वी विल बी एबल टू डिस्कस दिस थिंग इन डिटेल. सो नाउ अब कितने टॉपिक बचे? पोटेंशियल, पोटेंशियल एनर्जी एंड सैटेलाइट. वी विल डिस्कस अबाउट ऑल दिस टॉपिक्स इन नेक्स्ट सेशन. बट उसके पहले आप लोगों के लिए एक एडवाइस है कि ये सभी आपने ध्यान से देख लिया है. जो भी आपको नोट डाउन करने की ज़रूरत लगे वो सभी यू हैव टू नोट इट डाउन इन योर नोटबुक, एंड यूजिंग दिस कंसेप्ट्स यू हैव टू ट्राई टू सॉल्व एज मैनी क्वेश्चंस एज पॉसिबल. जो भी ना आए क्वेश्चंस ग्रुप पे रख दो, वी विल ट्राई टू सॉल्व. Okay, so we will continue in the next session. Till then, bye bye.